This is a current amplifier. So the input is what? Current. Yeah, the output is also current, right? So the gain is going to be equal to I out divided by I in. Okay. Now, based on the drawing here, what is the gain? Yeah, based on the drawing, not exactly. You say 1. Anyone have other answer? After this class, you really should be very careful about the direction.
Negative.
Negative 1, yeah. Okay. And I'm sure that for those who have never taken any electrical circuit, they can give the answer earlier than you because they clearly see that, hey, I think this one just go here, it must be 1, this must be equal to this one. But then because we know this is a transistor, you thought that there must be something more, right? So we are very hesitant in saying that this is 1. But when there's no channel length modulation, just go through the math, right, and small signal model. You see this must be equal to negative this, right? So the gain is negative 1. So again, we're doing something looks like useless. We have something like this before. What was that? The gain is 1. Source follower. But now you know source follower is not useless, right? What is the purpose of source follower? More ideal voltage source because you have a smaller output impedance. How about this? The input impedance is what? What is the input impedance? Low, 1 over GM2, right? How about the output impedance? R0. Correct, right? Now, how about the ideal one? You want to have 0 output infinite, right? So anyway, we don't want to have, this has a large output impedance, right? And it works well as a current amplifier. So now think about this. Under what situation I would need this circuit? Good. This stage may be a very nice circuit you have designed. It outputs a current. Whether it's an amplifier or just a sensing, maybe this is the current that is sensing, I don't know, some leakage, huh? Photodiode, very good. He said maybe a photodiode. We have a reverse bias one, and then we shoot on it, right? And then we have current, and it has a large output impedance. I don't know, small output impedance. Okay, let's see if that photodiode has a small output impedance. Or solar cell, for example.
Photodiode acts as a variable in this.
Okay, let's look at solar cell. For example, this one, right? It's open circuit. I don't know, maybe at this region has a very small output impedance. Okay, because this is I, this is V, right? So it's swap. So this part has very small output impedance. But by mentioned, maybe we don't want to use solar cell not to output current, but to output voltage. Let's go back to photodiode. Let's just assume that it is whatever. I'm not good enough to draw now. It has small output impedance, right? Then you want to sense it. Then what happened? You have small output impedance, you cannot sense it well, as we said earlier, right? So you go through this transformation, then you have a large output impedance, then you can sense it well. Okay? So that's what I want to say about this. Any questions? So maybe I can say this is as a current buffer. Okay, so we are done with the amplifier type. Looks like I spent a lot of time. I did, but I want you to really understand. And it's just like a tutorial, right? So now we have equipped ourselves with a lot of knowledge and insight. Now we can do the feedback. Because if you understand this well, then the feedback circuit will be easy to manage.